Welcome everybody to today's webinar. I am Jill Browning, your moderator for today. I can see that we've still got a few people that are logging on, so we will go ahead, give that another moment, and then we will get started shortly. Thanks for your patience. Okay, welcome everybody to today's webinar. As I said, my name is Jill Browning, and I will be your moderator for today's webinar on Water on Wheels, Mobile Clarification and Filtration. Before we get started into our presentation today, I do have a few housekeeping slides to go over. First of all, it should be obvious that you can hear me now, but if you do have any difficulties throughout, I do want to mention that there are two different ways to connect to the audio. You can connect either through your computer or through your phone line. So either way, if for some reason you do have any issues today, feel free to switch that over. And also, due to the large number of attendees that we have on today's presentation, we have gone ahead and muted everybody's phone lines. But don't worry, there is still a way to interact with our speaker. In terms of interacting with today's speaker, you can ask your questions via the questions panel at any time throughout the webinar. At the end of the presentation, we do have some time set aside for question and answer session with our speaker. So feel free to go ahead, ask any questions that come to mind throughout the presentation, and then we will try to get through as many of those as time allows at the end of today's webinar. And then if you haven't already seen, today's presentation is one of several that we are conducting within a 3-week live series. You can check out the complete series over on our website at www.veoliawatertech.com. You can take a look at those that are listed on there and register directly from there. And in addition to the live webinars that we are conducting, we have gone ahead and made our collection of on-demand webinars also available. This is a collection from over the last couple years, and we have posted those out on our website as well. You can also find those at www.veoliawatertech.com. One other housekeeping note here is a PDF participation certificate will be made available to you after the webinar today. You should receive that within 1 to 2 days of the webinar, most likely within 24 hours. So be on the lookout for that if that is something of interest for you to download. And then something fun to do, but also helps us, is your feedback. At the end of today's webinar, you will receive a quick survey requesting feedback from today's webinar. It should take you only 20 to 30 seconds. And for those of you who do complete the survey, you'll be entered to win or entered into a drawing for a chance to win a $25 gift card, Amazon gift card. So be on the lookout for that as well. And if you are selected from that random drawing, we will be in touch with you shortly after the webinar today. Okay, one more just quick slide before I introduce our speaker today. Veolia Water Technologies. We are a leading company within water treatment. We focus our key efforts, we focus our efforts in 3 key main areas: technologies, We offer advanced and robust water treatment technologies. We have a large portfolio of over 350 proprietary technologies that we're able to offer to our clients. In addition to the technologies, we are able to pair those technologies in terms of developing projects for our customers, as well as put multiple technologies together to meet required treatment specifications of the client. And then lastly, we do have a very thorough service offering that we can provide, whether it's during projects or after. And one of those service offerings that we will talk about a little bit today is mobile water services. Okay, now I'd like to introduce our speaker for today's presentation. Michael Reyes is the U.S. manager for Veolia's mobile water services fleet. Michael is a chemical engineer with 20 years of water treatment experience in chemical treatment, permanent equipment, and mobile water services. He has presented papers at various conferences, including the International Water Conference, Southwest Chemistry Workshop, Electric Utility Chemistry Workshop, and the American Institute of Chemical Engineers. He holds a BS in chemical engineering from Clemson University. Now I'd like to turn it over to Michael. Michael, are you with us today?
Yes, Jill, thanks for that introduction. I am very excited to be presenting today. And like perhaps many of the folks out there, I have the flexibility to be working from home today. So I did some of my own housekeeping to do this webinar. I locked up the dogs and I sent my wife and 4-year-old to the curbside pickup for groceries. So hopefully we won't have any major disturbances. So yeah, I'm excited to be here today. I've looked through our registration list and I've probably personally met about half of the people on the call. So thank you guys for coming and look forward to, talking with the new audience members that are there. So thanks again for joining us today to talk a little bit about mobile water services and a couple of the specialty angles of mobile clarification and filtration within the segment. So within mobile water services as a global platform and as a platform for Veolia, we cover a lot of different applications from the more common process water production with demineralization, reverse osmosis, filtration, the things that have been kind of the staples for mobile water services since they really began a number of years ago, as well as those technologies. Today, what I wanted to talk a little bit more about was one of the specialty angles or a subsegment of mobile water services, kind of the mobile clarification and mobile filtration piece of the market, or really what some people also call physical chemical stuff. So that's what I wanted to focus on today. We bring those models to the marketplace via equipment rentals, where we have either hands-off services or full services to the client. Some applications we're bringing to the table into the client site within a matter of hours or days. Some other ones are done with a little bit more planning and a little bit longer of a term that may be referred to as like design, build, own, or design, build, own, and operate. And most of all these applications in the mobile water world have the plug and play, where they're trailer mounted, skid mounted equipment that is able to arrive at the job site and have a lot easier installation than it would be for a permanent project, and then also demob out of there a lot easier. So when we look at mobile clarification, so what really drives the need for mobile clarification or mobile phys chem stuff out in the marketplace? And it really comes down to a couple of topics. One is, having stuff that is either planned or unplanned maintenance that happens to existing units out in the field without the extra installed capacity. If something goes down, that the clients start to stress and they need more capacity. So when we look at a typical large conventional clarifier, there are some moving parts in there. There's the rakes, there's the mechanisms, there's bearings that, given time, they can be problematic and create problems with those clarifiers. And then that sometimes creates either a planned event where the maintenance team says, hey, we need to get into this stuff here in a couple of months or this summer to do a turnaround, or sometimes, unfortunately, an unplanned event where there's a failure in the mechanism or a failure in the rake. We also see folks that do planned or unplanned activities on the actual tank itself, from the tank coatings, needing to get in and blast and coat a tank, or some of the structural steel components that drive the need to have mobile clarification. Sometimes a plant's production is increasing faster than their CapEx planning and their CapEx spend. So that also generates a need for this type of service. In some applications, we see degradation in the clarifier feed quality that can stress an existing unit to where they want to have a little bit more relief. And finally, one of the topics that drives the need in this business is, special projects that come up a lot of times in changes in environmental regulations that either come up quickly or come up to where it's a temporary event, and you would like to provide a temporary service for that number of months, number of years, like a dredging of a pond, dewatering of an ash pond, for example. And we've also seen applications where there can be significant, huge rain events that would drive the need to come to a site and provide more capacity relief in the surge ponds that would be there. So those are the things that that help drive the need for this type of services. So when we talk about clarification, if we go back to just the basic principles of that technology, we're typically talking about reducing the total suspended solids in a solid liquid stream through first doing charge neutralization, flocculation, and settling. So in the picture graphic here, what it shows is very small particles that are suspended in the water, and they have a natural tendency to repulse each other because they're of similar charge, and those things just don't want to settle unless you give them an extremely long period of time. So then what happens is typically a metal salt is added into that suspension, like an inorganic coagulant of a ferric or an aluminum-based product. In some applications, it's an organic coagulant to destabilize the particle charges. So those particles can collide together when they move about in the water stream, and they're mixed. So as those particles come together, they become more of a flock or a pin flock, but they still need to become a bigger size to actually have reasonable settling speed. And that's where a polymer or a flocculant is added into the water stream to help bridge those bonds between those smaller particles. So now you have a particle that can settle at somewhat of a reasonable speed. So if we look at Stokes' law, for example, that talks about this, Stokes' law says that if you've got particles that are, for example, 1 to 10 microns in size, it could take anywhere from 30 minutes to 55 hours for those particles just to settle 1 foot. So that can be very impractical to try to build a clarifier that big. And for that, Stokes' law is talking about particles that are similar densities of, let's say, silica sand, but then a lot of these colloids that are in there may have a density that's higher and unfortunately have a density that's lower. So that's where the aid of chemistry comes in to help with the settling. What Veolia has done is they've brought a technology to the table called ballasted clarification, and brought this to the marketplace probably over 30 years ago. And that's what I'm going to talk a bit about today. So with ballasted clarification, you're adding a ballast into this system, but you're still using the very similar coagulant and flocculants. So in the application here, the water is being treated with a coagulant, again, an inorganic coagulant, an organic coagulant, or a blend to form the pin flocks. And then while the flocculant is added, the microsand is added or recycled with this system to make a ballasted flock. So what happens when we look at ballasted technology and clarification technology, we do a lot of treatability testing or jar testing. So this picture here kind of demonstrates jar testing to some extent. That the picture at 3 seconds, what you see is the jar, the tube in this case on the left would be untreated river water. The center jar is depicting coagulant and flocculant. The jar on the right is coagulant, flocculant, and the ballast material. And you can see that after a very short period of time, the ballasted flocks settle extremely fast. You know, if we fast forward to these pictures to several minutes, 5, 10, 15, 20 minutes, the center jar would settle. And then if we fast forward to hours or days, the left jar with no chemistry in it would start to eventually settle. So ballasted technology has been around for about 30 years. It's kind of a loose definition for injecting or re-injecting a ballast material. And the technology that we use, it's really through recycling and reusing that ballasted material. But in the past, folks have used other ballast materials like bentonite clay to help speed up flocculant or do some other types of removals. And then, you know, even sludge or really dense sludge is also referred to as ballasted technology. And then there's some other dense inert materials that folks will use. You know, we've kind of focused in on the sand as a ballast and built our experience based around that over the last 30 years. And it's probably one of the most common ballast media that's used out there. As far as the jar testing, if you do visit my YouTube channel out there, I've got a couple dozen different jar test simulations that you can view at your leisure that show ballasted and unballasted clarification. So if we look at what really drives this technology of conventional versus ballasted, it comes down to probably one of the main things is footprint and a footprint advantage in the settling section of the clarifier. To put some numbers to it, for a typical standard clarifier, you're typically looking at rise rates of less than 1 GPM per square foot. However, that's going to be dictated on the settling velocity of those particular flocks. That's why you see the range here. A sludge blanket clarifier is a little bit higher. And then you start looking at other technologies like dissolved air flotation or incline plate settlers like lamellas, and the projected area allows for the settling, for improved settling in a smaller footprint. But then finally, once you add the ballast material, you can get those footprints pretty small and the rise rates pretty small. So that's one of the main process advantages is a small footprint, but it also can handle swings in influent quality, quick startups, which is important in a mobile project where you may be starting and stopping a lot during the project, and you don't have to wait to build that sludge blanket or sludge bed in the process. As far as the footprint advantage goes, it's definitely has its popularity in the installed base project, but in a mobile project, it probably is even more important because you can only fit so much stuff on the back end of a trailer. So the picture in the top left, these are examples of some permanent package active flow units that are probably, each one of those is probably treating 3 to maybe up to 5,000 gallons per minute per package. The picture in the bottom left is just a picture graphic showing, you know, the footprint difference from a conventional clarifier to a package unit. And then on our mobile platforms, you typically see, I'll call them 2 boxes. The front box we have is our motor control center, our HMI PLC, and some flocculant preparation equipment. And then on the back half of the system is a small modified packaged active flow clarifier. And with these trailers, we're doing anywhere from 1 to 2 million gallons a day of treatment. And that really can displace somewhere in the neighborhood of a 40 to 60 foot diameter conventional clarifier. So it's helpful to have that small footprint technology on a platform so we can treat those type of flows in a mobile job. Now, if we start to look at the technology, taking the jar chemistry into the actual equipment in the process, the way that these units work is we'll typically inject a coagulant in the influent stream to start the mixing or get a head start. We have a coagulation mix tank. We have a flocculation mix tank or a maturation mix tank where we're adding both the flocculant into it, and that's where we're also recycling the sand. So that flocculated and ballasted material then flow into our settling section, and that those heavy flocks settle very fast, and the clean water goes up through a set of incline plates or a lamella pack, and then out a set of weirs. And now in the bottom of that settling chamber, you have a combination of sludge and sand, and it's typically mostly sand because of the ratio of sludge to ballast material. And then that material is scraped out. It's pumped through a rubber lined centrifugal pump to the top of the unit where there's a hydrocyclone that then centrifugally separates the dense sand from the light sludge, and the sand is then recycled back into the process to repeat it once again. Also, if you visit either any of the Veolia websites or Google Veolia Clarifier, there's a nice 4 to 5 minute animated video that shows this process. So when we start getting in the due diligence phase of the project, it's trying to find out all the right parameters, talking to a client about what their projects entail, and how we can best serve those things. And some of the key questions that typically come up is schedule. How fast do you need to be at the client site, and how long are you going to be there? If the client needs you to the site and in a couple hours or a couple of days, you really have to pull from what's sitting in your parking lot and your fleet without much adjustment. If a client has a pre-planned project, that allows for more time for some modifications, or if it's pre-planned with long-term, even adding to the fleet. So schedule questions are very important to understand how fast we need to react, how fast we need to be there, and then how long we're going to be at the job site for. And then we start talking about performance objectives. I like to look at projects from the start as kind of a black box and talk with the client to understand, okay, what do you need to send to this black box? What's your flow range? What's your water quality look like? And talk about the water quality parameters that are important to them. Some applications, it may just be turbidity and TSS. Other applications, they may need to get into a variety of different metals and or organics. And then what are the objectives that are needed to come out of that black box? And then what do you do with the reject material, the sludge material? So those are all important questions to flush out in the due diligence phase. And then, shifting gears to do the treatability. What does the water look like on paper? Okay, can we get a hold of a 5-gallon sample and do treatability if there's time for it? So you can select, not just a broad spectrum coagulant or flocculant that work in a lot of applications, but you have time to find something that works more efficiently in a specific application. So those are all good parts of the due diligence project. Then when we try to take a look at the client's design basis and then what's in the mobile fleet, it's a little different than when you're doing a permanent design where you can design around everything. So a lot of times we try to look at and say, okay, well, what's going to be our bottleneck or limitation on the asset that we have in the yard? And it's not always the same thing. I mean, it could be rise rate like we're talking about in the hydraulics through the system, or it could be the reaction time that you need for the coagulant or the flocculant to do its job based upon the water temperature, or if you're doing metals precipitation. We run into some applications where it generates a lot of settled sludge that may dictate what kind of flows can be processed through a trailer. So those things are all kind of important in making sure that you have the right selection and the right expectation back to the client base. And then also understanding chloride, so you can make sure that you've got the right materials of construction. Some of the other things that we look at, pre-treatment, post-treatment, applications where if a clarifier alone or even a highly efficient clarifier alone still can't meet the client objectives, what else do you need to bolt onto the front or the back end of that? Filtration. You look at media filters, sand filters, high rate gravity flow filters. All those things come up in the discussions, as well as, okay, now what do we do with the sludge? Does the client have a dewatering device that can be used? Can that be put back into a pond or another impoundment? Or no, it needs to be thickened and pressed and hauled away to the right landfill during this project. Then you get into utilities. Are important to understand that, well, if I wanted to bring a certain technology to the table, does the client have that amount of power to run it? Or do we need to look at different technologies or a generator? And then kind of lastly, it's the space availability, the traffic that's going to go around these pipes that are going to be potentially on the ground and having the right crossings for those things. So we spend a lot of time talking about due diligence, and I just wanted to kind of plant those seeds with the audience base to, think about those things as we start to have projects float up. Now I'm going to dive into a few case studies, and really these are like one slide per case study. And if as individuals out there, you guys say, hey, we want to learn more about one of these individual case studies, reach out to us individually, and we can definitely dive into a lot more detail and share things that may be more applicable to what you think may be around your corner. So this first project we mentioned here, this was a client that was doing intake clarification into a refinery, and they found out that after after several years that the river water quality degraded, and it really was putting TSS and turbidity that was much higher than their current clarifier could handle, and at the same time the plant was producing more, so they needed more water. So they said, hey, do you guys have something temporarily that we can put in so we can supplement, so we can reduce some of the strain on our existing unit, make more water, and produce a better water quality for our refining process? And this was an application where the client utilized the temporary clarifier until they got their CapEx planning in and bought permanent technology to put in. So it was kind of a bridge gap for them until they could do that. This project here was at a coal-fired power plant in Oklahoma, and they had an impoundment that for their coal pile runoff that normally relied on, for the most part, evaporation to handle their needs. And they had a year that came up where they got 13 inches of rain in a month, where they typically averaged 4 inches. So this pond was filling up, and they saw more rain that was coming, so they called us in on an emergency basis and said, hey, help us pump and treat this water so we can relieve, so we have some working volume in here to work with. And after we did that, they said, well, just keep pumping it down while you guys are here. And what was very interesting about this particular project was that the water, even after settling in this, I forget, 50-acre or 100-acre pond, still had a lot of color and a lot of solids in it, because they were just such of a small micron. We go back to Stokes' law and see that these things really just never want to settle. So this was one that we had to look at different blended coagulants to really crack the repulsion charge in there, so we could form flock and then ballast it so we could speed up that settling. What was also interesting in this particular project was after the significant amount of the water was pumped away, that the client was able to get into areas of the pond that they normally couldn't get in with their earth movers and recapture coal. And it was, approximately $5 million of coal that they were able to recapture. This project we did up in the mountains of New Mexico, and from client phone call to contract was extremely quick, and from contract to deployment was just a matter of a couple of weeks to land in this case, which was metals precipitation reaction, clarification, filtration, and sludge dewatering. What was also interesting in this application is that the client was discharging to a trout stream, so they had very low levels of cadmium, copper, and zinc, but they also wanted to verify in real time those levels before discharge. So this one also included a mobile ICP laboratory and then a qualified technician to run those low-level metal tests, so they had extra confidence in the water as it did leave the facility. This slide here talks a bit about maybe applications we normally wouldn't do with a ballasted clarifier, but in an urgent and emergency basis, it's an available tool to be had. The first example was a power station that had a leachate from their coal process that they needed to treat, and it was a result of 3,000 to 4,000 milligram per liter of total suspended solids that we had to bring through the mobile unit, and this would be one where you have to look at the sludge generation and the settled sludge volume to figure out what kind of flows you can treat versus your normal rise rate, let's say rise rate bottlenecks. Another one at a chemical plant, this was following an activated sludge clarifier. So the TSS here again was very high, 3,000 to 4,000. But what's different in these two projects, and even the last one, was what I'd call the settled sludge volume, or the density of the sludge, and that plays an important parameter in how you would operate your unit, the abilities that your unit can handle, the amount of ballast material that you need in them. But these projects proved to be very, very effective for these temporary treatment of these high TSS applications. And you run into some of these that also have, can have an oil nature to them. And sometimes you have to have provisions so that the oily sludge can still separate very well in your hydrocyclone circuits. When we look at the filtration part of some of these mobile projects, this one's an example of a gravity flow technology called a Hydrotech disc filter that has the ability to handle screen sizes from 10 micron screens up to several hundred micron screens in size. This particular client had a conventional approach at their wastewater treatment. They had minimum equalization, oil water separator, dissolved air flotation, and a multimedia filter discharge into a POTW. And their sand filters or their multimedia filters were kind of at end of life, and they needed to replace those, but they were going to be replaced in the same footprint as the existing. So they needed to have a mobile filter parked on the side so they can get in and do the demo, the rehab, or the reinstall work on the multimedia filters. And this was one that we did with a trailer-based gravity flow disc filter for 2 MGD with up to about 50 milligram per liter of TSS. But what was also of interest was, the potential for, burps coming off the DAF system to be able to handle those through the filter. The pictures in the bottom left were screen pictures of before filtration and after filtration and part of our due diligence. And the next disc filter project, this one is at a municipal wastewater plant that is doing kind of a conversion from a lagoon-based system to an above ground system. So they've got this in a temporary path, the design basis here is around 1.5 MGD with suspended solids up to 60 milligrams per liter. So, we're able to provide a 1/100% unit here to do the fine filtration. And the advantage of this technology for these rental applications is the small footprint, the ability of flow you can do with one treatment trailer. And then they have an integrated filtered water compartment and a backwash pump, as you can see in this picture here on the bottom, already engaged in there, plus ability to do chemically enhanced backwash if you have a metal foulant or an organic foulant that's in the system. If we look up north, a couple quick examples of some case studies up there. This particular one was doing around 1,100 gallons a minute for 14 months, doing both clarification and sludge treatment. And in this particular example, it was also removing some organics. There's another example of one where some of the organics were removed in the clarification application, and another one where we added in a second train of the ActiFlow clarifier and recirculated powdered activated carbon to go after the organics. We called that the ActiFlow, or excuse me, the ActiCarb solution. So this particular case study here was, doing a mine impoundment treatment where we used 2 clarification trailers and 1 filtration trailer. And what's interesting about this one is that the other competitive alternative was using multiple reverse osmosis trailers. So using the physical chemical method, it was able to be done with about half the trailer footprint of the RO method, and then also use a significant less amount of power and not to have the RO concentrator, the brine to deal with, just the filter cake and the sludge. And then the results from this project and what the treatability goals were very low level of metals, even down kind of in the part per trillion range when you look at the copper and the cobalt. This was a gold mine application here again with clarification plus filtration and sludge dewatering. And then since these are kind of up in the far north of Canada, that they have the wintertime enclosures to keep everything warm, where, down in the States, sometimes we can get away with, pretty minimal runs of insulation on some interconnecting pipe, or do some other type of shelters that aren't, that don't need to be as weather resistant. This diamond mine application here up in Canada, this was one where we used a pretty high flow, gravity flow Hydrotech disc filter that was seeing much higher NTU than was first addressed on the bench. This particular unit had hydraulic capacities to treat up to about 5,000 gallons a minute. So kind of a few final thoughts here is, what might be your preventive maintenance and inspection schedules for your clarification process? What redundancies or spares do you have involved with those systems? Do you have tie-ins that if you did need to bring something in to supplement, that the tie-ins are somewhat readily available? And then if your plant is growing, kind of what are those plans for growth? Would it be CapEx investment, or would it perhaps be a services and operation-based investment? And again, if you would like any more details on an individual case study, just please reach out to the Veolia Direct, and we'd be happy to talk through those in more detail.
Great, thank you, Michael, for that presentation. We did have a few questions that came in throughout, but before we get into those, I just want to remind you, you can go ahead and ask your questions on or via the questions panel to the right. One other thing to note, there was a question that came in regarding today's presentation, if it would be made available to you. It is being recorded, and you will receive a copy of that in your email within the next 24 hours or so, I would say. So with that, I will open up the Q&A session. Michael, there's a question regarding the ActiFlow, why sludge is fed with microsand and not only microsand is used. And then also a secondary question to that as well is the diameter of the microsand, if you happen to know that.
Sure. So the the second part of that question, kind of on the sand, we have several different sand sizes that we use depending upon application. The sand is of what I'd call uniform shape and uniform density, and the sands kind of hover around a size of around 100 microns in size is pretty typical. There's some sizes that are smaller and some sizes that are higher. Again, depending upon the process needs of water quality, flow rate, and sludge characteristics help us drive the sand size that we would use or the sand selection that we would use. So we kind of go to our database of projects and compare those as a good place to start, and then we have the ability to modify that if needs be. As far as the type of ballast material that we use, we've typically focused on as sand as a ballast material and have the experience based upon that, with the exception that we also have a variant of the powdered activated carbon, and the one that's also used to do the organics removal. We have another technology called multi-flow that uses sludge or dense sludge, if you want to call it that, as a pseudo ballast material. And then we've done some conventional applications where we feed bentonite clay when bentonite clay has an added value piece of charge dispersion or absorption, but generally wouldn't recycle the bentonite clay. So yeah, that's kind of what we've done ballast wise.
Okay, another question is if the influent requires screening, can a mobile unit I cannot speak today. Can the mobile unit accommodate that?
Sure. So we typically talk about screening size, in the neighborhood of a quarter inch, give or take, depending on the size of the unit. And that generally goes with the clearances that are in the sand pumps and the hydrocyclones. So we first like to understand, does the client have the right screening or headworks in their process? And if they don't, we evaluate the risk of getting what I call that type of trash in the system that may either just be a nuisance every once in a while or a specific problem. And then we can add in the straining needs based upon that, whether it be a manual type of strainer or an automatic type of strainer. But it's definitely something on every project we ask those questions to figure out, do they have something there? Would it be a nuisance, or would it be a definitive problem we need to address? And we put those expectations on the table.
Okay, another question regarding the ActiFlow and microsand is how often is the microsand applied during continuous operation?
Sure. So typically at startup, we seed the unit with a certain concentration to get it up to speed, and then microsand is added based upon what I'd call the attrition rate. And for these mobile applications, it may be something in the neighborhood of as little as a 50-pound bag once or twice a week, or it could be something that is much more than that, depending upon the overall sludge volume. Like if we're doing an activated, well, if we're doing let's call it a pretty typical river water, wastewater application of moderate suspended solids, the sand attrition is generally pretty low. If we're doing an application that's high in suspended solids, like an activated sludge effluent, and we're handling 3,000 to 4,000, we're generally running a higher sand concentration. So then if you look at a higher concentration at the same efficiency, you have a little higher loss. Or if there's an oil or grease component in there, it may impact your attrition rate. So it is dependent from application to application. But in general, it's just a matter of adding a bag of sand as needed. In some of the larger, multi-million gallon day plants, some of those things are automated.
Okay, I've got a couple questions here regarding flow rate and so forth. First one is if you could speak to maybe the maximum flow rate per minute or perhaps per hour that a typical mobile unit can handle.
Sure. So the flow rate of our mobiles is anywhere from what I would say 500,000 gallons a day to 2 million gallons a day, or 350 gallons a minute up to 1,400 gallons a minute. Where on the low side, that would be for applications that are extremely high in suspended solids, like secondary clarification off an activated sludge system, for example. And then the higher treatment rates would be on applications that are, you know, the 1,500 milligram per liter applications, where, and then it's fine-tuned based upon the effluent quality the client's looking for, as well as perhaps the reaction kinetics on the coagulant, depending upon the temperature of the water, and or if you're doing metals precipitation or a softening application, for example. But those are generally the flow range of the treatment trailers. The package units that are for permanent, range all the way up to about 5,000 gallons a minute for a permanent, oversized shipment over the road.
Okay, in the essence of time here, I think we've got time for one more question. So in regards to treating TSS, what is usually the maximum GPM without losing effective treatment?
I would revert back to the question as before. The treatment flows can be anywhere from that half an MGD, 350 GPM up to 2 MGD, 1,400 GPM, based upon overall client projections, inlet TSS, outlet TSS, and other parameters.
Great. Thank you so much, Michael, for your time today. And we do thank everybody that joined us as well. If we didn't get to your question that you answered, we will follow back up with you individually. In addition to that, we do ask you to take a brief survey at the conclusion of today's webinar. Should take about 20 to 30 seconds. And for those of you who do complete that, you will be entered into that drawing for a $25 Amazon gift card. And then one final thing to note as well is if you enjoyed today's webinar and are interested in joining any of the other webinar series that we are doing, we do have a few more live webinars next week, as well as all of our previous webinars have been placed on our website. So you can access both of those at www.veoliawatertech.com. And we thank you all today for joining us on this Friday afternoon. Thank you guys very much.